Hi friends, a very good evening and thank you for joining in. Could you please confirm in the chat window, which thankfully I have access to, on if you're able to see me and hear my voice clearly, so that we can get started with today's session. Just wanted that confirmation. Again, we'll start the session in another 4 to 5 minutes. I tried to come a few minutes early just to ensure that there are no technical glitches. Okay, I see no problems because I'm trying to stream it back on my phone. Okay, cool. Everything looks good. Okay, no issues, which is always good. Good. Okay, so everything is clear. Okay, we'll get started by about 7:01 or 7:02 p.m. So yeah, if you have any questions, I can spend the next 4-5 minutes tackling 1 or 2 questions as best as I can. Again, as usual, we'll always have a Q&A at the end of it. Hey, good evening, everyone. Thank you for joining in. So, okay. So, Shavik says, are the lectures for every subject complete? Yes. If there is any change in syllabus, we will surely update as and when the official notification from GATE comes through, right? Like last year, there were a bunch of new concepts that got added, some concepts that got deleted. So we will edit the syllabus if there is any change as compared to last year, right? Cool. So Deepyan says it's a tricky situation, Deepyan, that you're in, because you're trying to manage the internship that you're currently doing, of course, the GATE preparation and the college work. Again, the best strategy that I can recommend you is compartmentalize your day. Tell yourself that, okay, in these 1 hour or 2 hours or 3 hours, I'm going to study only GATE. In this period of time, I'm going to give my fullest to my internship so that I can get a pre-placement offer. And in these hours, I'm going to study for college. So I think compartmentalizing can surely help you. Again, please be very, very disciplined. Try to break your whole day into 90-minute chunks. Give your fullest in those 90 minutes, whether it's GATE preparation or the work that you're doing as an intern or your college coursework, right? With that, I think you will be able to balance. I understand that instead of just college and GATE preparation, now you have a third thing, which is internship. I completely understand that it is slightly tricky, but it's doable. You just have to be more disciplined in chunking your day and working through it. Cool. So Rohit says, I have COA in live classes. I have not completed DM yet, of which I have recordings. Shall I do DM first or attend live COA? Again, that's a choice you have, Rohit. I mean, there is no one right answer to it. Again, we typically recommend students to finish discrete mathematics and engineering mathematics because it's very scoring. And it's also easier to score as compared, I mean, I'm talking about an average student. It's easier to score in discrete mathematics than in computer organization. So we would recommend students to first finish discrete mathematics and then go to computer organization. That's what we would recommend. So this is by Gautam, who says, is it too early to prepare for GATE 2023? Just to give you a personal viewpoint, I started, again, when I was in my BTech, this was between 2003 and 2007. I was very clear that I wanted to crack GATE. So I started my GATE preparation in my after my second year, second semester, during that summer holidays, right? So I started literally after my second year, second semester exams over, I started like doing it thoroughly. I gave my GATE examination in the third year itself. I got a good rank. And of course, I tried to better that rank in my fourth year. So if you're planning for GATE 2023, it's not too early. We have a lot of students who do prepare. So it's fairly common because you can take the GATE examination in third year now and also take it again in the fourth year, right? So a lot of students try to get it through in the third year so that fourth year they can focus on placements, other aspects, right? So, I mean, if you can crack it in third year, all the benefit to you, right? So this is by Bitu, who asks, how many hours should I practice problems? Like that depends on what stage you are in. Like, for example, if you're a repeat student, you should do more problems now because you've gone through the concepts already. Of course, you should go through the concepts that you don't know well. But in general, if you're doing the gate for the first time, because this is your first iteration of learning, spend more time understanding the concepts, slightly lesser time on problems now, but over a period of time. So right now you can do like a 2:1 ratio. For every 2 to 2.5 hours that you're putting in learning the concepts, spend about an hour on solving problems. That's what you can do in the early stages. But going forward, slowly, as you're going closer and closer to the examination, because you'll be revising what you've just learned now, you will spend like 20% of your time on revision, 80% of your time, even more sometimes, even 90% of your time on problem solving as you keep going closer to the examination. At this point, even if you're spending 30% of your time on problem solving, that's okay, because first you have to understand the concepts without which you can't solve problems, right? Again, our team members have pinned the whole this live session schedule itself. We have changed it. Anyway, so let's get into the session itself. Let me start sharing my screen. Give me a second, please. Okay. My screen should be visible. Can you please confirm that in the chat window? Is my screen visible and my voice audible? I have a couple of quick announcements, then I'll get into the session itself. Is my screen visible? Can you please confirm? Okay, so my screen is visible, right? So again, I'll come back to tackling general questions on the chat window at the end of the session, right? I'll spend some time on it. So this is the third problem solving session, the interactive problem solving session related to theory of computation. The topics in today's problem solving session is context sensitive languages, Turing machines, and undecidability. You can typically expect anywhere from 2 to 4 marks from these topics. Again, once in a few years, you get a question from context sensitive languages. Most of the times you get questions from Turing machines and undecidability, anywhere from 2 to 4 marks. Our next session is on the coming Tuesday, which is a public live session, which means it will be on YouTube, accessible to everyone. The next session is compiler design, and these are the topics. Again, in the sheet that we have pinned in the chat window, if you go to that sheet now, you'll see the whole plan. So for example, and you'll also see which live session is public, which live session is for course enrolled students, etc. Right? So all those details will be here. Cool. Again, this is the same sheet, same Google sheet that is pinned at the top of the chat window. Right? So if you go to the chat window, you'll see it pinned at the top. For example, if you go to the chat window, you'll see this at the top here, right? So that's what I'm talking about. So a couple of quick announcements and clarifications based on suggestions that we got from students. So some of our students mentioned that, requested us not to put the label that a question is easy, medium, or tricky. Because the moment we put it, when we show you a question, it is biasing the student's mindset while tackling the problem. Because in the real GATE examination, nobody tells you these labels. So what we are doing from now on is, when we show the question, we will not say whether it's an easy question, medium question, or tricky question. You solve it while explaining the problem, while discussing the problem solving approach to it. Then we will say whether it's easy or between easy and medium, is it tricky, and things like that. Now, the second important announcement is, instead of one live session a week that we were initially thinking of, we are tentatively, most likely we'll be conducting 2 live sessions every week. One will be on Tuesday, one will be on Friday. Again, some of these will be private, and some of them, by private I mean they'll be accessible to course enrolled students, and some of them will be public. So if you want to get the whole schedule and follow us through, please go through the Google sheet that is pinned at the top of the comments, right? Again, that will take you exactly to this sheet. So today we are doing theory of computation 3, right? Turing machines and decidability theory. Then the coming Tuesday we have compiler design. Then the next Friday we have compiler design, and these are the topics, and so on and so forth, right? So again, the fundamental reason why we are trying to do 2 live sessions is because of multiple reasons. One is 2 hours per live session, because when we try to solve 8 problems in detail and discuss about the problem solving approach itself, again, if you see the last session, it took us almost over 2 hours. And we also want to spend some time on Q&A, right? So 2 hours is a lot of time commitment for a live session like this. So students have reached out to us and said, hey, can you conduct 1 hour session so that it's faster? And you can do it multiple times in a week. So the plan here is we will do 2 live sessions, Tuesday and Friday, 1 hour each. And in this 1 hour, we will solve about 5 problems, interesting problems, and then we will have a Q&A at the end. Please remember that the focus of these live sessions is not the volume of questions. It's not just the number of questions. It is to teach you the problem solving skills. It is to help you build the problem solving skills and how to approach different types of problems. That is our core philosophy here. It's not saying, hey, I solved 5 questions or 50 questions. If you build the problem solving skills, even with 5 problems, you can solve another 50 problems that are thrown at you, right? So that's the key here. So with that, again, I promise you that we'll spend some time in Q&A at the end. So let's go into the first question itself. It's 7:06, so let's get started. Here is your first question. Again, if it's an MSQ, I will mention that it's an MSQ. Otherwise, it's an MCQ by default. I will not say whether it's easy, medium, or hard. Please figure it out and solve it. Yes, this session is a public session. That's why it's on YouTube. You'll be able to access it after the session is over also. This is a public, all public sessions are accessible to everyone via YouTube, not just course enrolled students. Again, please focus on solving the problem because that's the reason you all are here. That's the reason we're also here. So please spend time on, okay, let me just increase the font size. Okay. So please focus on solving the problem. General questions we will surely answer at the end, right? So please. It's an MSQ, so multiple options can be correct. Again, this is a context sensitive grammar. Please be careful. Take time, it's okay. Please be careful and patient. TOC is very scoring if you can solve these simpler problems carefully without making silly mistakes. So one of the students is suggesting to put a timer. Right now I'm not doing it fundamentally because right now it's not about the speed of solving, it's about accuracy. Once you solve enough problems, you'll get speed. Gate is never about speed. Okay. As soon as sufficiently good number of students answer the question, I will explain the solution. Again, partially correct answers will give you 0 marks. While there are no negative marks for MSQs, if a subset of your answer is correct, then you would get 0 marks. So please take time and think through carefully. I will answer general questions about skipping a topic or not at the end. So please let's solve this. I see a lot of your answers being only partially correct, or I should say partially incorrect. I've seen like a wide spectrum of answers here. Most of them, almost 90% of them are partially correct or incorrect. Again, it could so happen that I am wrong, but we'll solve it together. Please revisit your answers. About 20-30 people have answered, but there are many mistakes or partially correct answers. So please revisit your answers, please. Thankfully, some of you got it right without doubt. Now, this is a very simple question. This is all about verifying if a word can be generated by a grammar. It just so happens that this grammar is a context-sensitive grammar, and hence it's slightly harder. If it was a context-free grammar, then you have the standard parsing trees and concepts in compiler design that you can use. This is slightly harder because it's a context-sensitive grammar. It's actually not a hard question, but okay, some of you got it right, which is good. But there's a good chunk of you who got it partially correct. Okay, so let's tackle the question itself. Let's go step by step. Okay, so at least we believe that this is an easy question, but typically given for 2 marks, because you have 4 words that you have to verify whether they're generated by the grammar or not. It is easy because all you need to know is how to generate words and verify whether words can be generated using a grammar. That's why it's an easy question. But it is also lengthy, right? It could take some time to, especially for options C and D. A and B are easy. Option C and D could take some time because if you have to generate these words, you have to be more careful, right? So it's an easy question, but a lengthy question, and hence often 2 marks question. Okay, so let's go step by step. We are given AB. Again, there is no trick here. It's a very straightforward question. So we start with the starting symbol S. S generates SBA, right? Now we want to generate AB, right? Now the problem here is you have 3 symbols here, right? We know that B generates B. So eventually I can generate this B. We know that A can be generated by S, or this additional A can be generated if I have lowercase a followed by uppercase a, which means a terminal A and a non-terminal A, right? Only then I can generate this A. But here I have 3 symbols, which means whatever I get will be at least 3 symbols long. So I cannot generate this string AB, whatever I try, right? Because I have 3 symbols here and there are no epsilons. Nothing is generating an epsilon here. So what is hard here is this B could eventually generate a B. This A will eventually combine with something else, because if you have BA, you can replace it with AB, right? If you have BA, you can swap it and say, hey, this generates this, right? But the problem here is this AB. Now this A eventually, whenever you replace this A, you're going to replace it with at least 1 symbol like this, right? Or this A, this BA can be swapped into AB. So there is no way you're generating a word with only 2 characters. So obviously this cannot be generated. Simple. Now let's look at this AABB, right? So we'll go step by step and carefully think through this. Okay. So let's say S generates SBA. So our goal is to generate AABB. So let's try to see, this requires patience. The reason this problem is lengthy is you have to think of all the ways through which you can generate this. You can't apply concepts in compiler design because this is not a context-free language. This is a context-sensitive language. Okay. So let's go step by step. So I want AABB. Let's assume I replace this with A. Now I have my BA, right? What if because BA can generate AB. So I try to generate AB because I want everything to end with B. Look at this. I want my word to end with B. That's why I'm swapping this, right? Now let's see what I can do here. So what if I do this? What if I do, look at this. I also want more A's. I only have 1 A. How do I generate more A's? From A, I can generate more A's if I want, right? So what I'll try to do here is I'll try to now say, okay, from this B, let's generate a B, right? So what I have is AA lowercase b. Now this lowercase a uppercase a can generate AAB again further. So I can say AAB. I have this B here. I'll just copy paste it as is. Now this B can generate a B, right? Again, look at how, again, you have to think very carefully because what you want is something that starts with A. You want 2 A's followed by 2 B's. So you finally got AABB, right? Again, this is just the parse tree. You can think of it like a parse tree, right? For the grammar. So B certainly is the right answer, which is good. Now what about C and D? That's where things get tricky. Most of you got it right that A is not the right answer, B is not the right answer. C and D is the tricky part because as the length of the string increases, there are more possibilities that you can do, and hence you have to be much more careful now. Okay, so let me draw the whole parse tree. So let's assume I have SBA. Remember, I want A's and I want 3 A's and 3 B's. Okay, let's see if I can generate it. Okay, so I have SAB. I'll go step by step here. Again, there are many possibilities, but we'll have to keep playing around with it. While generating all of these, while drawing this parse tree, as it's called in compiler design, or while creating the next set of terminals and next string of terminals and non-terminals, I'll always keep this in mind. Okay, so that's what we have to do. So let's assume I say, okay, this S, let's assume I say I'll convert it into A because S can generate A. This BA, let's assume I say, okay, can I do something smart with this? Or else let's do this, because just having this may not be sufficient because I have many A's and many B's. So S can generate SBA. So maybe I want to use it, because if I from S, if I generate A, I'm only left with BA. BA can be replaced with AB, and then there is very limited string length that I can generate. Because I want to generate a longer string, maybe this is a better approach. So I will say from S, I will generate SBA. This BA will stay the same, so this BA stays here, right? Now I can make these BAs into ABs. So let's try to do that, right? So this BA I will replace with AB. Now I have my S here, right? So this BA also I can replace with AB, right? This BA also I will replace with AB. Now if you notice, there is one more BA here, right? There is one more BA. So let's keep going. So SA, A, one second. So I have SAABB, right? Because this BA got replaced by AB here. Now it looks like I have enough what do you call it, non-terminals through which I can generate a longer string like this or this. So let's continue going here, right? So okay, I'll just write this here, right? So that I can keep growing this tree, right? I'm just writing this here. Okay, just for the space. So from this S, if I generate A, right? Okay, that's cool. So from this S, I generate A. Then I say I have my SA, right? One second. I have AA, BB. Okay. So what if I do? I'm just thinking slowly, step by step. Because from this I can create B. From this I can create A. From this I can create B. That part is straightforward. So okay. So let me just write this down. So A, B, B. Now let's think from here. Right, so A, double B. Now I have this AA, lowercase a, uppercase a. This I can increase it into AAB, right? So what I'll do here is I will say I want AAB. This ABB I'll keep it as is. Now this BA, look at this BA, because if I have enough B's here, see, the only way I can generate a B is through this capital B. The terminal B can only be generated using variable B. So I'm trying to get as many B's as possible here. That's what I'm trying to achieve. Because I have 3 B's here. I need to be able to generate 3 B's here somehow. Right? So I'm also keeping that in mind. So when I have BA, I'll swap this with AB. Right? So I'll swap this with AB. And I get my BB now. Now if you think about it, now what can I do? So I have my A, capital A, triple B. From triple B I can get triple B. But what will happen to this A? This A is stuck now. Look at this. When I reach here, this A, because just using A, I can't reach a terminal symbol. I need to somehow combine lowercase a with uppercase a to get this. This I can get into AAB, right? Because B generates B, right? So the only way I can, so if I get 3 B's here, I'm stuck with this capital A, which is a non-terminal, and I can't go any further. So a better strategy here is take this lowercase a, uppercase a. Lowercase a, uppercase a can generate AAB, and I have my 3 B's anyway. Now, if you observe, what you have is 4 B's. There was no way I could get 3 B's at the end with 3 A's at the beginning. These 4 B's now, each of them can generate a lowercase b, right? Because of this production rule, right? So I'm able to generate AAA 4 B's. So which means this should be the answer. But is there any way, is there any step in this whole process that I can change so as to get AAA triple B? Can I change something? For example, here I can't get rid of it, right? So again, when I tried to generate AAA followed by some B's, I got 4 B's, not 3 B's, right? That's what I was trying to do. I was trying to have enough number of non-terminals here so that I can generate at least 3 A's, which I'm able to get, but also I should be able to generate enough number of B's, right? So if you track back now, if you track back and say, hey, can I somehow get rid of one of these B's? Now, how do you get rid of this B? right? So if you want to get rid of one of these b's, you should not use this production. But if you don't use this production, how will you get rid of this capital A? Because capital A onto itself, the only way whenever you have an A is you have to either use this production or this production, right? And for this production, you need to have a lowercase a in front of it, which we don't have. So there is no way, if you keep backtracking and ask yourself, hey, can I somehow generate only 3 B's along with 3 A's? If you keep backtracking, you'll see that it's not possible, right? So B and D are correct answers, A and C are not, right? Again, this process is lengthy, right? This process is lengthy. This is an easy question. It is a lengthy question because A and B are easy, but the problem here is C and D, because the length of these strings is larger, right? Because the length of the string is larger, this whole parsing tree that we are constructing is also longer, and it's much more easier or much more harder to make a mistake. So my only rule that I try to apply here is that I want to get good number of B's and good number of A's. If I want to get good number of A's, this is the strategy that I have to employ. If I want to get all the B's to the corner, look at this. By doing this, I'm swapping A and B here. This production rule is literally swapping A and B. So what I'm trying to do here is I'm trying to push all the B's to the end, because I know from the capital B I can generate lowercase b's, right? So the simple rule that I was trying to do while solving this problem is try to get as many lowercase a's and capital A's to the left and as many capital B's to the right, right? And in this process, I could not generate C, I could only generate D, and you can verify that you can't generate C. It's a lengthy process, but if you're patient, you will get 2 marks very easily. Most of you for this problem answered B, or you answered B comma C. Or some of you even answered ABC or ABCD also. Some of you also answered BCD, right? But the appropriate answer here is B and D, right? Again, you have to be careful. That's all. There is no shortcut here, right? There is no shortcut. Again, these questions are intentionally given to be lengthy. That's why you get 2 marks for it. There is no shortcut here. You just, at least not that I know of, to be honest with you. Again, simply making sense of context sensitive grammars is harder, right? Again, some of you might say, hey, I have a context sensitive grammar. Can I create a linear bounded automator from this? Again, that's a non-trivial process. Understanding the logic behind this grammar itself is non-trivial. That could take more time, and that is often done through examples like this, right? So this is a easier method, or this is more of a lengthy process. I agree with you, but it's a guaranteed way to get 2 marks. But you have to be careful. Very, very easy to make mistakes. We have seen for similar problems, people make mistakes left and right. Again, from context sensitive grammars, once in every few years, you get a 1 or a 2 mark. You don't get it every year. Once in a while, you get it. Cool. Let's go to the second question now. This is very nice. I hope everybody can see this. Okay, I'll move this to the right. Again, the font size is a little small because there's a big diagram here. This is about a Turing machine. Again, please read all the options. It's an MCQ because nothing is mentioned about its MSQ property. So understand the Turing machine. Please work out. Anyway, I'll leave you there. Please take your time. Don't be in a hurry. Don't make silly mistakes. It's an MCQ. Hence, it's slightly on the easier side if you think about it. B2 has a question which is, do they give long questions in GATE exam? Yes, they do. They do give slightly lengthy questions sometimes. Like last year itself is an example. Set 2 GATE 2021 is a lengthier paper. For sure it is a lengthier paper. Of course, lengthier questions also translate to 2-mark questions. But typically TOC is very scoring. You can almost score 90+% marks in this. Please be very careful with your choice of answer. So Aminur is asking, can I apply CYK algorithm for CSG grammars? From what I recall, the CYK algorithm is meant for, it's like a dynamic programming approach for context-free grammars, right? I'm not sure if it works for context-sensitive grammars. I don't remember it to be. At least at the top of my mind, I don't think it works for CSGs. At least at the top of my mind, because when you say CYK, I always think of context-free grammar in Chomsky normal form. It's basically a dynamic programming tabular approach. Anyway, let's focus on this current question. Sorry. Okay, there are broadly two options everybody is picking, B and D. Let's see the answer, right? Okay, let's go step by step. So you're given some Turing machine, the whole diagram is given to you. Okay, cool. So B is the blank symbol, got it, very nice. So first always read the 4 options. This says, this is basically a language of words where number of A's and number of B's are the same, okay? So here it says number of A's is 1 plus the number of B's. Very simple, nice. This says, okay, A power n, so A's followed by B's, right? And this says B's followed by A's. It's a union of both, and n should be greater than or equal to 1. Cool. This says A power n, B power m, where number of A's is 1 more than number of B's. This says number of B's should be 1 less than, okay, number of A's should be 1 more than number of B's. There is a union. Okay. So when given a question, there are 2 approaches here. First, you understand the whole Turing machine and solve it, or try to construct examples to eliminate options. Okay, simple. Let's look at one of the smallest strings that this can accept. Suppose I start here, right? Suppose if, let's say my word is, okay, let's construct one of the smallest strings. If it's epsilon, right? I mean, again, if your word is epsilon, there is no epsilon transition anywhere here, right? So you're done. But let's assume it is A. Suppose if your word is A, okay, you have B, you have blanks before and after that, right? You're starting here. So then what happens if this is x0, sorry, you are in this state, initial state. If you see A, what you do? You say, you'll replace that A with X, right? So you replace this A with X and then you move to the right. So you go here. Okay, let me erase this. Okay, so you change this to X, okay, and you move to right. Okay, cool. Now I'm in this state now. In this state, okay, so what are the options, right? I've replaced it, I've gone here. Cool. Now in this state, what do I have? Look at this. So from this state to this state, because this is a final state, if I have blank, replace it with blank and move right, right? Of course, my string contains all blanks. So you replace blank with blank and move forward and you've gone to a final state, right? So one of the smallest strings that this accepts is just A. Now using this, let's eliminate. What does this say? This says number of A's and number of B's should be same. So this can't be the answer because you have one A and you have no B's. This surely can't be the answer. Now what about option B? Look at option B here. Option B says that the number of A's is one more than the number of B's. This can be the case because there are 0 B's here and there is 1 A. This may be the option. Maybe. We don't know. Okay, we'll have to construct, because we'll have to eliminate other options also, right? It may be the answer. Let's look at this option. This says A power n, B power n, n greater than equal to 1. Forget about this part. Forget about this part for a while. So this says A. So in this, you don't have just a word A. This language does not have just a word which consists of a single terminal symbol which is A. It doesn't have that. So this also can't be the option. What about D? Okay, D says A power n, B power m, m equals to n plus 1. Okay, which means A power 1, B power 0 will satisfy this condition. Oh, so this also may be the answer. Right? So what have we done? Very simply, we have said, okay, B and D may be the answers, this or this. Surely we know C can't be the answer, A can't be the answer. Now can we construct an example to eliminate B or D? Let's see, in this you have strings that can start with B also. Let's construct one string from this, right? So B power m, right? So let's say B power 1, A2, right? Because, right? So this is BAA. So this is a string or this is a word that belongs to this language. Now if I input this to the Turing machine, what happens? I'm starting here, my B. So B will take, okay, so let's write it carefully. I think that's a better thing to do, right? Because there could be all sorts of transitions. So what was our BAA? Our word is BAA. So before that you have blanks, after that you have blanks, obviously. So you're starting with B first, right? I'm just putting a dot here. You're starting with B. It takes you to Q3, right? And you're replacing B with X, okay? You're replacing B with X. You're moving to the right. Now you're here. Now when you're in this state, look at this. Once you're in this state, if you get an A, what happens, right? If I get an A, I will go to this state, right? If I get an A, okay, so you have B, X, A blanks, right? And blanks before this, obviously. And you're at this state now. And you're in Q3. So let's just say you're here and you're in Q3. So Q3 on A will replace this with Y. Okay, so let me just write that down. So this will replace this with Y. And it now says go left. So I will go here, right? And I'm right now in state Q4. Cool. Let's see what happens here. Okay, so cool. Now I have X here. Okay. Now if I get an X, what happens now? Look at this. If I get an X, what happens now? I have my X, right? I have my X here. On X, I go back. So I replace X with this. I go to the right, right? Again, I go to Q0, right? I've gone to Q0. So there is Y here, right? If I keep getting Y's, I keep moving. I keep going to the right. Okay. Let's just parse this. Let's see what happens here, right? So I move to the right. So because on Y transition, Y is replaced by Y and I move to right. Now here I have A, B, B. A followed by blanks. Now if I get an A, what happens now? Look at this. If I get an A, I will just go to here, right? And I'll replace this A with, so I'm in Q0 state now. If I make a mistake, just let me know, please. So I'm in Q0 now, okay? So on A, what happens now? On A, I'll replace this A with X and I'll go to the right and I'm in state Q1. Q1 on blank, right? I go to the right and I reach a final state. So again, let's just redo it just to be careful. So we had an input BAA. This was our input, right? BAA with blanks and before and after. Now remember, BAA will BAA occur here? Number of A's is 1 plus, by the way, the problem here, I'm sorry, I took a wrong example, because BAA satisfies both condition B and condition D. I'm sorry. So just because BAA is accepted, you can't eliminate B or D, because we are stuck with B and D, right? Okay, sorry, I'm sorry. So let's take a better example now. Okay, so let's take a better example. Let's take a better example that will help us eliminate B or D. Now, okay, let's say I have B power M and A power N, right? So I'm just thinking of an example. Just give me a second. Okay, so what if we have, so we want something that belongs to B and not D, or D and not this, right? So just give me a second. Let's think. Let's say ABA. Now, if you see ABA, okay, so if I take this word, right, this word has number of A's as one more than number of B's. So this satisfies option B, but it does not satisfy D, because in D you have A's followed by B's, or you have B's followed by A's. You can't interleave A's and B's. Now what happens with ABA? Of course you have blanks here, right? I'm sorry, I took a wrong example, right? We should always take examples that will help us eliminate, because that's a faster way to solve the problem. Okay, cool. Okay, so ABA. So we start here, we are in Q0. On A, what do? We go here, we replace this with X. We go here, we are in Q1. Now on Q1, if I get a B, what happens, right? I go here, right? Q1 on B, I replace this with Y. Okay, let me just, again, okay, I replace this with Y and I go left. I replace B with Y and I go left, and I am in state Q2. In Q2, if I get an X, what happens? I replace X with X and I go to this state. So I go to Q0 now. Now what happens? In Q0, I got a Y. If I get Y's, I'll keep staying in the Q0 state and I'll keep moving to the right. Now I got a Q0. So Q0 on A goes to Q1. And of course, this gets replaced by Y and I go to Q1. Q1 on blank reaches final state. So if my word is ABA, this satisfies, ABA belongs to this language, which is option B, but not to option D, right? So when we eliminate, simple rule of thumb is, whenever we have a problem like this, elimination using simple examples, right? The first thing that I always try is I try to construct the smallest word that can be created from this. And from the smallest word that we saw was just A. That helped us eliminate option A and option C. Then you are left with option B and option D. Pick something that will help you distinguish between option B and D, like this word ABA, because here this word we know for sure doesn't belong to D, but it belongs to B, right? That's the experimentation that we have to do, right? Simple logic. Cool. So I hope, again, this is simply elimination by building simple examples. Of course, there is an alternative approach which could again take time, which will help, which can also be done, which is, you see the logic here, right? You say, hey, whenever I get A's, whenever I get Y's here, again, understanding the logic in a finite automata is easier, right? But here the biggest problem here is you have the tape and you're replacing the tape. You can move right, you can move left. So understanding and deriving the logic sometimes becomes trickier, especially with Turing machines. So when you have an MCQ like this, sometimes elimination is the fastest approach. Again, most of you either said B or D. I think those of you who said D did not think of this option, which is ABA, right? So always try to come up with counter examples whenever you have to choose between two options like this. Cool. Okay, sounds good. Okay, where are we? Okay, let me just open the chat window. This is MCQ, right? This is MCQ. Okay, so let's go to the third question. This is an MSQ. Oh, this is a nice question. Simple question. Sorry, I can't tell you whether it's easy or hard. I'm sorry. Again, these types of questions are very, very common in GATE. These are like properties of recursive languages, recursively enumerable languages, decidability, undecidability. I mean, this is a very, very popular concept that is often asked. This is an MSQ, so please be careful. Multiple options can be correct. We would rate it as an easy question because it actually is easy. Happy to see many of you got it right. This is a very, very standard type of question about properties of recursively enumerable and recursive languages that you see in most GATE questions. I think there are a couple of follow-up questions on the previous question that our team is answering one by one based on the examples that you're giving. Okay, so most of you got it right, so happy to see that. Good, good, good. Again, you have to know the properties and closure properties of recursively enumerable and recursive languages. So let's go through each of the options. First option, right? What is given? L1 is recursive language. Again, I have to write it like this, otherwise I get confused. This is recursively enumerable. Again, you might have seen all of this in our course videos. Again, a lot of a good chunk of concepts related to Turing machines, etc. are publicly available on our website. So if you're interested in some of those videos, you can check it out. Yeah, so cool. So let's get into this. Okay, so L2 star, which is basically a clean closure of L2. So if L2, so L2 is recursively enumerable, right? So L2 closure is recursively enumerable. L1 closure is also recursive, right? Because L1 is recursive, L1 closure is recursive. Closure, they both are closed under RECs and RELs are closed, or recursively enumerable and recursive languages are closed under clean closure. And union, obviously, right? You have a recursively enumerable language. Union, a recursive language, will be a recursively enumerable language, right? So cool. So this is true, obvious, like no brainer. Because remember, every recursive language is also a recursively enumerable language, right? So you have a recursive language. So the relationship is like this. Every recursive language is recursively enumerable, right? It's all about the termination, right? Whether you have a total Turing machine or a Turing machine. That's the ideas from machine's perspective. Cool. So this is true. Next is L2 complement, right? L2 complement is recursively enumerable. No. So L2 is recursively enumerable, right? So this is, I just don't want to make the mistake. So I'm writing it here because I often confuse whether L1 is recursive. I've done this mistake in the past. That's why I'm double careful. So L2 is recursively enumerable. So L2 complement is not necessarily recursively enumerable. So this option is not true. Again, this is something that we have shown in the course videos also, right? Suppose imagine I have a machine M. Again, the proof of it is literally like 2 minutes proof, right? If you want to prove it. Suppose imagine I have a machine M2 that accepts language 2, right? Which means if I give a word W that belongs to this, it will either accept, reject, or it will go into an infinite loop, right? Now I want an L2 complement, right? So if I want to construct a machine which accepts L2 complement, so let me call it M2 complement, right? If I give it a word, that word will be passed through this. If it accepts, I reject. If it rejects, I will accept, because the complement, I want to construct a language that accepts. So this machine corresponds to L2 complement, right? This machine corresponds to L2. So if M2 accepts, I will reject. If it rejects, I'll accept. But the question mark here is, if it goes into infinite loop, will I accept or reject? Very simple proof, right? So you can't, so given L2 to be a recursively enumerable language, which means you have a Turing machine which either accepts, rejects, or goes into the infinite loop. L2 complement, you need not be recursively enumerable, right? So cool, that's it. So this is B is not true. Again, this sort of proof we have explained in the course videos, some of them publicly available, you can please check them. So this is true, this is not true. L2 star, L1 star. Okay, this is concatenation. Okay, got it. So we know L2 star, so it's talking about recursively enumerability, right? So this is simple. Remember, L2 star is recursively enumerable. So this is also recursively, so L1 star is recursive, right? Because recursive languages are closed under clean closure. All recursive languages are recursively enumerable. Now we have concatenation of recursively enumerable languages. That is also a recursively enumerable language, concatenation, right? So C is also the right option. So A is right, C is right, B is not right. Let's see D. L1 complement, right? So L1 is recursive, so its complement is also recursive. Because when you have a recursive language, whenever the word belongs to the language, if you have a machine like this, right? Let's assume this is the machine for L1, right? It always accepts or rejects. It never goes into the infinite loop. So the complement you can easily build, right? For accept, you give reject. For reject, you give accept. So constructing a machine for this is trivial. So this is recursive. What about this? L2 is recursively enumerable. So L2 complement need not be recursive, right? So this, need not be recursively enumerable. Oh, so you have an intersection of a recursive language, which is obviously recursively enumerable also. But the second part need not be recursively enumerable. Because you're taking intersection, there will be some languages in this. So yeah, you can't say that this is going to be recursively enumerable. You can't say that. So option D is also incorrect. Only A and C are correct. Only A and C are correct. Yes, this is an MSQ, right? Yes, A and C are correct. That's it. Very simple. Again, if you just, again, the reason I said this is an easy question is, if you just know the properties of recursive languages and recursively enumerable languages, you're good. I just wanted to show you something interesting because there are, okay, so just let me go to gate.applied roots. I'll just show you this because some of these videos are interesting. I really enjoyed with my team creating some of these video content. So if you go to Turing machines and undecidability, so there are some of these videos in Turing machines, like for example, the closure properties, right? So languages of Turing machine and closure properties. Similarly, more closure properties of recursive languages and recursively enumerable languages. So these videos are free, where actually I go into the details of it. I show how to prove it and things like that. So it's publicly available. Similarly, in undecidability also, there are some interesting proofs about halting problem, right? So what is a non-recursive enumerable language, right? The diagonalization. So there are some free videos which you could benefit from. So please check them out if you're interested. Cool. Okay, so let's go to the fourth question now. This is interesting. This is a very nice question. Again, for some of the follow-up questions, our team is trying to answer them. Again, if there is any mistake that you have found or anything that is not clear in our explanation, please email us if you're not able to solve it in the chat right here, right? I'm just trying to move little fast because we have two questions slightly on the lengthier side. Because for me to explain the solution process takes time. Again, we are giving more MSQs because that will prepare you, that will push you to look at each of the options, right? More practice basically. In the same question, if you want to give more practice, MSQs are the way. I'm very happy to see the answer for this question. Very happy to see it. Very good. Of course, some of you have partially correct answers and things like that. But we have solved similar questions in our course videos. We have derived some of these things also. Okay, the question says which of them are decidable. Got it. This is a very good 2-mark question about undecidability and decidability. Again, there are multiple ways of thinking about, there are multiple tricks that I'll also discuss, because I think we have a couple of problems about decidability, if I'm not wrong. Yeah, so we have a couple of problems, and I'll try to tell you a couple of approaches that I typically employ. Okay, since a good chunk of you have tackled it, in the interest of time, I'll also go into the solution. So for most decidability, undecidability problems, there are a couple of tricks that I employ, right? The first one is I try to use the Rice theorem. I mean, it's there for a purpose, right? It's a very beautiful, elegant theorem. And if you can translate the problems that you're given into the Rice theorem, right? Rice theorem is simple. Every non-trivial property of recursively enumerable languages is undecidable, right? Straightforward theorem. Probably one of the most elegant and beautiful short theorems in whole of mathematics that I've ever studied. So if you know Rice theorem, you can simply apply it to say, hey, this language is undecidable, right? So this is one strategy that I strongly recommend. The second strategy is ask yourself, can you write code? Can you write code? Because what is a decidable? See, the moment you say a language is decidable, you have a total Turing machine or you have a halting Turing machine. So ask yourself, hey, in any programming language of your choice, can you write code which always terminates, which always halts, right? If the answer is so, then the language has to be decidable, right? Third thing, use properties. I mean, there is a huge list of properties that we describe in our course videos about various properties, mostly decision properties about languages. Try to use them. These are, again, there is a fourth strategy, which is try and prove by contradiction. Of course, the reduction methods, right? So you have the reduction method where you try to reduce a problem into a problem that you know is surely, let's say, undecidable, right? So you try to reduce it to a problem which you know is undecidable, and then you say, hey, if this problem was decidable, then there is a very popular known problem or very popular known language which is also decidable, and hence proved by reduction. That's why proved by contradiction. So you do a reduction plus contradiction, right? The problem here is reduction plus contradiction is a lengthy process. In GATE, very often using just these first three approaches, you can solve most questions about decidability. Sometimes you will have to apply this method, but oftentimes this is not needed. Okay, I mean, there's nothing wrong in doing it. If you can do it, all the power to you. But it takes more time to construct, because it's like literally constructing a mathematical proof through the reduction mechanism with a contradiction, right? So here, let's see what we can employ. So L1 is basically all encodings of Turing machines M that reject all inputs of even length. First of all, let's write the Rice theorem for those of you who may have forgotten it, right? So what does the Rice theorem say? Rice theorem simply says every non-trivial property, right? Every non-trivial property of recursively enumerable languages is undecidable. Now we know what is a trivial property. Imagine what is a property P. Again, this is something that we explain in a lot of detail in our course videos, right? A property P is a set of recursively enumerable languages that satisfies the given property. right? So this is what it is. Now we know what is a trivial property, what is a non-trivial property, etc., that we have described in our course videos, that I'm assuming participants here know it, right? So let's go in here. So let's go for L1. L1 says it is an encoding of Turing machines that reject all inputs of even length. So let me construct a property P, right? I'll call it not even. So this property P is a set of all recursively enumerable languages. Again, this you have to be careful with, right? It's a set of all recursively enumerable languages, because I know that a Turing machine, when it's encoded into a binary format, right? It's the binary encoding of a Turing machine is a recursively enumerable language. So the set of all recursively enumerable languages that represent a Turing, I'm just writing it very carefully for you so that you get the flow of thought, right? That represent a Turing machine, right? That rejects even length strings, that rejects, I'm writing it slowly and carefully, even length strings, right? That's what is your property P, right? Property P is a set of all recursively enumerable languages that satisfy this condition. Now, remember, what does Rice theorem say? Rice theorem says, look at it, every non-trivial property is undecidable. Now, is this a trivial property or a non-trivial property? What is a trivial property? P is said to be a trivial property if P is an empty set, or if P is set of all recursively enumerable languages. If P is a null set, or if P is set of all recursively enumerable languages, then P is said to be trivial, right? Now we have to determine whether P not even, this property, which is nothing but the set of RELs, is it trivial or non-trivial? Now first and foremost, imagine I'm trying to construct, look at it this way. Imagine if I'm trying to construct a Turing machine that rejects even length strings, right? Of course I can construct a Turing machine that rejects even length strings. I can do that, right? Because I can do that, this P not even is not a null set. It's not a null set. The set has some elements. But is every recursively enumerable language satisfy this property? No. There are so many Turing machines that will not satisfy this property. Imagine if I have a Turing machine that accepts even length strings, right? So certainly P not even is not the set of all recursively enumerable languages. So this is also not equal to the universal set of all recursively enumerable languages. Because it is not a null set, it is not equal to the union of all it's not equal to the set of all recursively enumerable languages. Then obviously this is a non-trivial property, right? So this is a non-trivial property. If this is a non-trivial property, from Rice theorem, we know that it's undecidable. This is a flow of logic here, right? Very simple flow, but the flow is important. So which of the following is decidable? Surely A is not decidable. Same logic I can apply to L2 also. Look at this. For L2 also, I can construct a property and say property which halts on empty input, right? Halts on empty input. This is going to be set of all recursively enumerable languages, right? Such that it represents a Turing machine, that halts on empty input. That halts on empty input, right? So again, if you observe, this set PHE is not a null set. It's not a null set because I can design at least one recursively enumerable language which represents a Turing machine that will halt on empty inputs. I can do that. Again, this is again not equals to the set of all recursively enumerable languages, right? So this is again a non-trivial property, again using same logic as option A. Again, using that you can say, hey, this language that you have using Rice theorem is also undecidable. Very simple logic. So A is undecidable, B is undecidable. C. Okay. Again, this is a very standard example that is often asked. Again, we have solved similar problems in the course videos also. So what does it say? It says L3 represents Turing machines on binary strings that accepts in less than 100 steps. Like, look at this. Can you write code for it? Obviously. Because if you have all the inputs, look at this, take all the words of length less than equal to 100, all the words. Again, this set of all, because this is binary strings, right? Look at this, all the words that you can generate of binary strings of length less than equal to 100 is a finite set. This is a finite set. It's not an infinite set. It's a finite set, right? Because the length has to be less than equal to 100. It's a finite set. So you simply enumerate through all the strings all the binary strings of length less than equal to 100 and say, hey, on any one of them, does my Turing machine accept at least one of them? If it doesn't accept any of them, you just say reject. If it accepts any one of them, you say accept. You will never go into the infinite loop because the set of binary strings is finite, right? So obviously A is not decidable, B is not decidable, C is decidable. Oh, this is straightforward. D is surely decidable because M is a DFA, right? Deterministic finite automata, which corresponds to regular languages, right? So from your R is a regular expression. Regular expression also generates regular languages. So what we are looking for is equivalence of regular languages. Again, I told you about the decision properties, right? If you look at decision properties of languages, given two languages which are regular, can you verify their equivalence? Yes. There was this big table that we described in the course videos, right? In the table, there are all the decision processes, right? Whether it is finite, all the properties here, and then you have regular languages up to recursively enumerable languages. And I taught a mnemonic, a memory trick to remember this, right? I often forget it. Like today morning while solving this problem, I went and saw this whole table, revised it myself because I tend to forget it. We all do. So you'll have to think of some memory tricks that I've described in the course videos to keep track of this. But we know that equivalence of regular languages is a decidable problem. So answer is C and D. Many of you got it right, which is good. But my objective here is not to tell you the answer, but the approach. These four approaches that I just described earlier, which is most problems you can solve using Rice theorem, using code-based halting approach, or using the decision properties of languages. Sometimes you'll have to build this, but very, very few times. Less than 5% of questions in GATE, you might have to build this, right? So I hope this is clear. Cool. So let's go to the next question now. I think most of you got it right, which is always good. Okay, cool. Okay, so let's go to the fifth question now. Again, there are some follow-up questions which our team will discuss, right? Okay, cool. Okay. Anyway, I got it. Okay, so let's go into the fifth question. This is a straightforward one. Again, our team is trying to answer your follow-up questions on these. Actually, I was trying to finish this in 1 hour, but we have overshot. Again, if there is any mistake in the answer or explanation we've given, or if it's not clear, feel free to ask us. Okay, so this question already people are putting their answers. Okay, let me just see. Which of the following are false? Okay. Okay, there is a small problem. I think many of you may not know Boolean satisfiability problem. I should have explained it in this question. So, okay, I'll explain C just for the benefit of everyone. So, a Boolean satisfiability problem is that you're given a Boolean expression of variables, right? So, let's assume I have variables x, y, z. I can construct a Boolean expression, right? X and y not, or any Boolean expression, right? X and y, if x and y then z, any Boolean expression that I can construct of variables, of course, finite number of variables. Now the Boolean satisfiability problem says, hey, is there an assignment of Boolean values like 0, 1, whatever? Is there an assignment of values, Boolean values to these variables such that this Boolean expression results in true? Okay, or is there, are there values like x equals to 0, y equals to 1? Can I give some values, right? So given a finite number of Boolean variables and a finite Boolean expression, is there an assignment of values to the Boolean variables such that this expression is satisfied, or in other words, this expression is true? right? That's what is called the Boolean satisfiability problem. It's a very standard problem in NP completeness. Anyway, so for those of you who don't know, I hope you understood this. Now, the first option is straightforward, right? I think some of you may not know the third option. Rest everything is straightforward, right? Again, Boolean satisfiability. I'll come to Boolean satisfiability. Again, I think we can explain it in like one sentence. I'm sure there is a very neat one sentence explanation of Boolean satisfiability problem. It's called the SAT problem in computer science. It's called the satisfiability problem. Anyway. Again, there are many ways of talking about Boolean satisfiability. What I gave is probably one of the simplest, because I am assuming that you guys know what is a Boolean expression and things like that. Okay, so let's get into this problem so that we can spend some time on Q&A. The question of whether two DFAs accept the same language is decidable. Again, this whole thing boils down to the decision problems about languages, right? I mean, there are a bunch of decision problems about various languages, from regular to recursively enumerable. Again, there is a huge table that we describe with a mnemonic in the course videos, with a memory trick. A mnemonic is nothing but a memory trick, right? So if you know all these properties, it's just about applying these properties, right? The question of whether two DFAs accept the same language, right? Again, it says which of the following are false. Okay. So you have deterministic finite automata, which means you have regular languages, right? What you have here is regular languages. So from a language perspective, okay, so whether from a language perspective, it's saying are two regular languages the same, right? Is that a decidable problem? Yes, it's a decidable problem. So is this undecidable? No, false. A is false, right? Okay, cool. Next, again, it's saying which of the following are false. So A is false. Next, the question of whether a given Turing machine halts on all inputs is decidable. No, right? This is also false, right? How do you say that Turing machine halts on all inputs, right? You can't say that for sure, because I can create a very convoluted Turing machine or a piece of software or code which you'll have to iterate through the infinitely possible number of strings in a given alphabet that can be generated from a given alphabet, right? So this could get stuck in an infinite loop, right? So this is not decidable, and hence this statement is false. The Boolean satisfiability problem is undecidable. It's actually the Boolean satisfiability problem was one of the first problems in computer science that was discovered to be NP complete, right? Think about it, right? Imagine if I have a Boolean expression like this, X and Y or Z. Let's assume I have three variables. I have some Boolean expression, right? So I have look at this. I have three variables here, and each variable can take a 0 or 1. So I'll simply enumerate through all the 2 power 3 possibilities here, enumerate through the exponentially many possibilities that I have here. That set is not infinite. It's just exponential in the number of variables that you have. It's not infinite, right? I will simply try X equals to all the possible combinations and all the possible combinations of values that I can give to X, Y, Z, and see if there is any assignment that will result in this expression being true, right? So that again, since you guys don't know, probably if a question like this was given in GATE, they will also explain about what is Boolean satisfiability problem, right? Again, it's a very, I mean, it's a phenomenally beautiful concept, and it was the first language that was proved to be NP complete. And whenever we want to prove other languages to be NP complete, we do use Boolean satisfiability and the whole reduction mechanism, right? The polynomial time reduction and things like that. So this is decidable. So this has to be false, right? So we tick this. The question of whether two context-free grammars generate the same language, right? Okay, so one second. So context-free is undecidable. So the moment you have context-free grammars, they generate context-free languages, right? So the equivalence, again, in the decision problems about languages, in our course videos where we discussed this, we showed that the decision the decision problem about two CFLs being equal, the equivalence of two context-free languages, is undecidable. So this statement is true, hence we won't tick it. So A, B, C are the answers. Right? Simple logic here. Cool. With that, I'll wrap up today's session. Again, please note that there is a session on Tuesday, which is the 25th of May. There is a session on 25th of May. The topics would be, it's a public session. The topics will be from compiler design, syntax analysis, parsing, and SDTs, right? Again, there was new syllabus that was added for compiler design last year. So that's why we are doing 2 sessions for compiler design, because you could run into simple questions. Even last year when questions were asked on data flow analysis, a little bit of code optimization, they are very simple questions, right? So the 25th session, which is the coming Tuesday, is a publicly available session. Again, because we have overshot, again, please check out these videos. You might like some of them, and please give us feedback on that. Again, if you're not satisfied with any answer, or if you have a counter example, if you think something is incorrect and we could not resolve it in this session because we have overshot on time, please reach out to us over email. We will correct it if we made a mistake. Okay, cool. So let's go into the chat, because I want to spend some time on the chat window also. That's what I promised you earlier, right? So, okay, let me just pull up my phone and see your questions. Let's go into the general questions discussion, because I skipped that at the beginning of the session, right? Okay, so the best book for Turing machines that I can think of, let me share the screen. I think I've mentioned this also. I mean, this is the book that I learned, right? So Rajiv Motwani, this is called Theory of Computation. Again, this is the same old book. Oh, it's also Rajiv Motwani, Stanford. 1 second, let me just open it. Yeah, unfortunately, he died in an accident. Again, for those of you who don't know, Rajiv Motwani was one of the earliest funders of Google. He was an advisor to Google in the very early days, and he has some terrific, brilliant research work in algorithms. Okay, so yeah, here is the book. Okay, this is the 3rd edition. It's a rewrite of the Hopcraft-Ullman textbook. The earlier versions are harder to read. This is the best version. This is Automata Theory, Languages and Computation. Please see that there is Rajiv Motwani here, because his explanation is easier to understand for undergraduate students. The older versions of this are only meant for like research level students. This is the book that I read personally, and I've referred to this book extensively throughout our course. Cool, sounds good. So that's what I would recommend. If I have to pick a book again and read, that would be my book. Okay, so let's go into the questions again. Again, for whole theory of computation, that book is like golden. So, okay, what to do for, again, somebody asked this question, what to do for problems we don't know in exam? Simple, remember, the GATE exam itself is like what, 70-75 marks, right? It's a 100-mark paper, but the toppers, if you want to be in the top 100 ranks, I think if you get like 70-ish, you're in the safe zone, right? So you don't have to get everything right. You can skip 30% of the questions, or you can skip 30 marks and still do well on the 70 questions and get good marks. That's perfectly valid. So don't try to, again, there are students who get 90 marks, but those are like extremely rare, depending on the easiness of the paper or the hardness of the paper. As long as you're in the first 100, 200 ranks, it really doesn't matter. Your outcomes in your career or your learning will not change if you're in top 100 or top 200, right? Cool. 1 second. Okay, so there is a very nice question, which is by this guy called T Master. I think that's an alias. Okay, so his question is very nice, and it's also very pertinent. So he says, should we try to finish the syllabus as soon as possible without solving questions, or take time with solving topic-wise questions? Please, for heaven's sake, don't skip problem solving in your first iteration of learning, because we have seen a lot of students who just go through the syllabus. They think they understood everything. They have not. Okay, and they will forget all of it also if they don't do it through problem solving. Please, I mean, I cannot emphasize this enough. After you learn a bunch of concepts, please solve problems. The purpose of these whole live sessions is also to chunk the whole syllabus till October and break it into chunks and conduct these live sessions. Problem solving is extremely important. Don't postpone it to the end, because then you don't know what you're lacking. You don't know where you're headed, right? So please solve it, even if it takes time, even if it is hard. It is the process which is important. Please don't skip problem solving to the end. We would not recommend it at all. Okay. Cool. So Amit says, is banking IT officer job worth it for computer science students? Again, I don't have a lot of context about it, to be honest with you. When I don't know, I think I'll have to tell you that I don't know. I've not interacted with enough people who work as IT officers in banking sector, but it's a choice that you'll have to go through. So again, talk to other people who have been there. I don't have any of my friends. I have friends who are like the POs and then who have become branch managers or divisional managers and things like that, but not in the IT department. So I don't have first-hand knowledge about it. Cool. Let me just scroll down. Yeah, Amar, I keep using the word. I can't emphasize this enough because I really, really want to emphasize that. Okay. So is it necessary to solve all problems in the first iteration of learning? From Abhishek? No. So just make sure you're solving a bunch of medium level problems and few easy problems. Again, a simple rule of thumb that we can tell you is for every, if you're following the course videos, right, you don't have to worry, because after every bunch of concepts that you learn, about 10 hours or so, you have a practice test, right? Then after you learn concepts, again, you have practice tests. At the end of the subject, you have subject tests, live sessions like these and things like that, previous year questions, etc. So don't try to solve everything, because if you're trying to solve everything in the first iteration, the problem is you don't complete the syllabus. Keep enough questions for the second and third iterations. Simple thing, if you're a course participant, solve the practice problems and the subject tests or subject problems that you have at the end. That should be good enough to get started. Okay. So this is from Aditya, who says, is a 2-year drop a bad idea for GATE CSE? I would think so, Aditya. 2 years is because worst case, you should always prepare for worst case in life and career. In case, worst case, you don't get into GATE with a good rank. At the end of 2 years, you have 2 years of career gap. And most companies will be reluctant to hire you at that point, looking at your career gap, even if you have skills. Right? That's unfortunate reality of the job market. So then you'll have to get into an intern, work there hard, and then work your way up, which could take time. So again, GATE preparation can be comfortably done by working professionals with full-time jobs. Like in my class at Indian Institute of Science, I think about 40% of my batchmates were working professionals. Even today, if you see a lot of toppers that we talk to on a regular basis, a good chunk of them are working professionals. One thing that helps them win is consistency of preparation. They don't give up. There is always a roller coaster ride of emotions. One day you'll think I'm going to get a single digit rank. Other day you'll think, will I even qualify? That happens to all of us. It happened to me. It happened to many of my teammates. It happens to all toppers. Just be consistent and keep going at it. Right? Don't fall into the trap that, hey, I'm not going to get it ever. So please don't drop 2 years. Cool. How many times one should solve previous year questions? Again, I'm just scrolling randomly, picking up general questions. Again, Sudeep, it's not about the number of times you solve. It's about, again, I think I've mentioned this in other videos that are posted on our YouTube channel. It's never about solving the questions n times. It's about solving it once perfectly. Don't look at the solution, struggle with the question, solve it. All the questions you could not solve it the first time, give it some gap. Give it maybe a couple of 2 to 3 months. Revisit those questions when you're revising the subject. Right? 2 times, I think. Again, the second time you're only solving questions that you could not solve the first time. It's not about remembering something by heart. It's about building the problem solving skill. Right? So this is from Mallikarjun, who says, in how many months should we complete watching videos? Again, there is no one book or one method that works for everyone. We have students who finish the first iteration in 4 months. We have students who take 8 months to finish it. And we have seen students who took 8 months who got a good GATE rank. We have seen people who finished it in 4 months who got a good rank. Everybody has a different different learning rate. Everybody learns differently. So as long as you're completing your syllabus by December end, I think you're in a good shape, because you can focus whole of January and February for solid revision. You can do 2 revisions in Jan and Feb, right? So at whatever pace you're going, be judicious with your time, be truthful to yourself, don't look at the solution, struggle with the problem, revise the concepts. I think you're in a good shape. So again, we've seen the whole spectrum of students. We have seen people who complete all the course videos and even practice problems in 4 months, and then they don't put in effort afterwards, and they don't crack the gate because they've forgotten everything come Jan, right? So cool. So somebody's asking about applying for roles at Applied Roots and our whole organization. The way we typically hire is we conduct an online test, publicly available across India, and we have few tens of thousands of students who take it every year, and we get interns from that. It's a purely, I mean, I don't care whether you're coming from an IIT or whether you're coming from a smaller college. It's a pure skills, pure meritocratic test. We shortlist a bunch of candidates, interview them. Like last year, I think we had about 20 interns, some of whom converted to full-time, right? So we follow purely meritocratic approach. Again, we don't even look at resumes very often. We say, hey, if you have skills, please prove it. It doesn't matter whether you come from Stanford or you come from a smaller college. It doesn't really matter, right? So again, most of our hiring is through these exams or internship exams. Even for our AA course and other courses, every candidate who reaches out to us, or students or folks that we hire, it's all through a exam-like method. Okay, cool. So this is for somebody. Aryan says, I'm a second semester student. I want to crack GATE in 2022. That's good, because as somebody who is just getting into your 3rd semester, I believe your 4th semester is getting over now, and you have your GATE exam in the 6th semester. Just make sure that you're also covering GATE subjects in line with your course curriculum, because in 3rd year, 1st semester, you might have a subject like computer networks or compiler design. So go with the flow, but just make sure that you're not just stuck to those subjects that you have. And I think there is nothing that's stopping you. I mean, a lot of students crack, who prepare genuinely well, crack GATE in their 3rd year, like including myself, when it was available during my times. Like I started my preparation after my 2nd year, 2nd semester exams are over in the summer, and like 7-8 months, more than sufficient to crack. Again, even though there were subjects that I never studied till my BTech final year. Cool. Okay, so sounds good. Okay, so this is from Sahil, who says, once I lose momentum, it's difficult to be back on track. Happens to all of us. So my suggestion that I'll give you is try to build a routine or a habit, right? So one thing that works very well for me is as soon as I wake up and brush, I just make myself something hot to drink. And that puts me, like I get my chai or coffee, whatever I make early in the morning, I get it to my desk. I have that, I check my email, and then I go for a run. So I have this routine, right? I have this literal routine. Again, I'm not able to step out because of COVID. I just do basic exercise at home. But I have this whole routine of falling in the routine will help you not lose track of things. Again, this is all based on the habit forming stuff that I've also described on our YouTube channel. Please check it out. The essence is this: have a routine, like just like the way after you wake up, you brush your teeth before you have your breakfast. It's the same process, right? Just get yourself into a routine and things will be magical. You'll see really, really big things happening like in a very short span, because I've experienced it myself. Cool. So Akshay says, should I quit my job because I'm not able to cope with the preparation of GATE? Please, for heaven's sake, don't quit your job. Please, I mean, I cannot emphasize this enough. That basically means, like, I'm emphasizing it a lot, triple star, 10 stars. Please don't quit your job, because if you don't make it through GATE, you have a career gap, which you need to justify to recruiters later, right? And this whole 1 year of income is lost. So if, I'll tell you brutally, honestly, right? If you're not willing to put in 2 to 3 hours as a working professional, then something is wrong in your planning, day-to-day planning. I understand that for some companies and teams, the work can be hectic, but you need to manage that work Try and finish it in 9 to 10 hours. Get out of all social media. Get out of all the things that are distracting. Spend 2 to 3 hours a day, and I think in 8 to 9 months, you'll see tremendous results. Please don't quit your job, because you should always prepare for you should always think of the worst case scenario, like the worst case time complexity of algorithms, right? Think of the worst case. You drop a year, you quit your job, you don't get a good rank. What happens then? If you get a good, it's like if you get a good job, very good. But what if you don't? Sorry, if you get a good rank, that's great. But what if you don't? Right? So you should always be prepared for that. We strongly recommend you don't quit your job. The test series 2022 will be launched in June. The exact date, we're just finalizing, we're just setting up the questions, etc. So it will be mostly in, I think, middle of June, hopefully. That's what we have as an internal target. So this is from Rakesh, which is, can I get enough time for placement coding preparation after GATE exam if now I prepare for GATE? Yes, Rakesh, because think about it this way, right? In GATE preparation, you're building problem solving skills. You're learning data structures, algorithms, coding, the basics of it, not the state of the art that you require for competitive programming at the highest level, but the basics. And once you finish your GATE exam in mid-Feb, you can just go all out on your preparing for placements. You still have 3-4 months, and you have your strong foundations. You've prepared a lot of programming practice, and most importantly, you have problem solving skills that will translate into competitive coding also, right? So cool. One second, I didn't understand this question. So Srinivas basically says how many hours to give to GATE preparation. That differs from person to person, but for an average student, try to give about 3 hours a day. If you think you're an average student, 3 hours a day is a good start. Of course, as we come closer to the examination, you might have to put in more time. At this point, 3 hours makes a lot of sense, right? Cool. Okay, sounds good, guys. So Sunita is asking about Boolean satisfiability problem. Again, this video will be available on YouTube. You can always check it. The best thing is just type it on Wikipedia. There is a very simple, nice explanation. Of course, there are many variations of satisfiability. There is 3-SAT and various variations. Bottom line is this. If you have to summarize it in like 1 minute, you're given a Boolean expression, a finite length Boolean expression, and you have a bunch of Boolean variables. You have to determine what values you can assign to each of these Boolean variables such that the whole expression is evaluated to true. Right? So that's what Boolean satisfiability basically says. Is there one assignment of variables, one assignment of Boolean values to these variables such that the whole expression is true? Right? This is one of the simplest ways to put it. Cool, sounds good. I think we have covered a bunch of general questions. Again, please check the Excel sheet that we have, which has the whole schedule. Again, we are avoiding the 2 hours because we are avoiding the 2 hours live sessions because it's harder for people. And any questions that we could not explain here, or any further clarifications on the questions, or in general questions, please reach out to us over email. We'll try and resolve as soon as possible. Thank you very much, folks.